Eric Burgess here, and we have another sequence. They want us to determine an equation. Just a reminder, n starts at 1. So it's the variable we typically use to express sequences. And it starts at 1 and begins to go up in integers on and on and on forever. So we want to somehow get this pattern out is usually the game plan. So looking at this, what patterns do we notice right off the bat? Well, first off, this beginning part looks a little funky, like nothing really clear here. But over on the last three terms, we can see a pretty clear pattern, right? On the top, we have patterns that's powers of 2. 4, 8, and 16 are all powers of 2. And the bottom is powers of 3, 3, 9, and 27. So let's go ahead and rewrite those first. So we've got a negative. This is 3 to the first, and this one is 2 squared. And then we have 8, well, that's 2 cubed, and the bottom is 3 squared, that's 9. And on the top, we have negative, and this one is 16 is 2 to the fourth, and 27 is 3 cubed. So if you know your powers, your life will be a bit easier with this one. And then coming over here, well, we say, well, if this pattern continues, then we would go down to 3 to the 0, right? Because we're going down in this direction. And the top would go to 2 to the first. And if we look at this, well, 3 to the 0 is 1, and 2 to the first is 2. So that gives us 2. So we've got that one figured out. Our first one is negative. And if we keep the pattern going, this would be negative 1, and this one would be 2 to the 0. So if we look at this, well, 2 to the 0 is 1, and 3 to the negative first, well, we'd do the reciprocal because of the negative power, and we would get 3. And then the negative sign would just, stay where it's at. So it turns out that these three, if we figure out these three, we can just do the first two pretty easily. So this is the pattern that we're looking at. And again, we are looking for how to rewrite this more generally, right? Because it goes on forever. Well, n starts at 1, but our sequence starts at negative 1. So we need to shift this over 2 spots. So the bottom part of our sequence is going to be 3 raised to the n, because that's where our numbers start. We're going to subtract 2, because when we put 1 in, it'll be 1 minus 2, which is negative 1. So we'll be starting at the beginning. And then for the top, we have 2, but 2 starts at 0. So we only have to subtract 1 off to start at 0, right? Because we start at 1, so we do 1 minus 1, that's 0. So that's going to be what we want. So we're going to do n minus 1. And then finally, we need to do the negatives. Now the negatives, the first one's negative, and so we're just going to go ahead and slap a negative 1 in the front and raise it to the power n. Now, I've talked about this trick before. This is the way we generally deal with, every other negative, these oscillating negatives. And we choose n because n will start at 1, and negative 1 raised to the first is 1, and the negative 1 squared will be positive 1, so this would be positive. And this will go ahead and alternate every other one. So we will get our signs as they should be. So that's how you do a question like this. There are other ways of writing this answer. I consider most of them to be more complicated than they need to be. I think this is really the most straightforward way to write this. But there are other ways you could express the same thing. If you arrive at something slightly different, but you can reorganize it to look like this, then we have the same answer. If you have any questions, feel free to let me know. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.